Hello, this is my Module 4 Advanced Concept presentation on generating acetyl-CoA from pyruvate. So I'm going to show you some diagrams that I drew and provide explanations along the way. Okay, here we go. So this is an overview of pyruvate dehydrogenase. And so it lists all the steps, but we're going to go into more detail. So in the mitochondrial matrix, pyruvate is oxidatively decarboxylated by the pyruvate dehydrogenase complex to form acetyl-CoA. The irreversible conversion of pyruvate into acetyl-CoA is the link between glycolysis and the citric acid cycle, also known as the Krebs cycle. The pyruvate dehydrogenase complex is a key step in metabolism. It is the link between glycolysis and the citric acid cycle, allowing complete oxidation of glucose. So this process involves 3 enzymes. And so these enzymes include pyruvate dehydrogenase, dehydrolipoyl transacetylase, and dehydrolipoyl dehydrogenase, in addition to 5 coenzymes. And the 5 coenzymes include thiamine pyrophosphate, TPP, lipoic acid, and flavin adenine dinucleotide, FAD, which serve as catalytic coenzymes. CoA and nicotinamide or tinamide adenine dinucleotide, NAD, are stoichiometric coenzymes. Stoichiometric coenzymes function as substrates. So as we can see, the conversion of pyruvate into acetyl-CoA consists of 3 steps, including decarboxylation, oxidation, and then transfer of the acetyl group to CoA. So the next diagram shows the process of decarboxylation. And so during decarboxylation, the pyruvate combines with the ionized carb-anion form of TPP and then decarboxylated to yield hydroxyethyl TPP. So this illustrates those steps involved. The rate-limiting step in the synthesis of acetyl-CoA is catalyzed by the pyruvate dehydrogenase component, which is known as E1, of the multi-enzyme complex. TPP is the coenzyme of pyruvate dehydrogenase component. So next we have oxidation. And so during oxidation, the hydroxyethyl group attached to TPP is oxidized to form an acetyl group while being transferred to lipoamide, which is a derivative of lipoic acid. This transfer leads to an energy-rich thioester bond. The disulfide group is reduced to its disulfhydryl form in this reaction. The reaction is catalyzed by E1, resulting in acetyl lipoamide. So that is oxidation. And then this next step is the formation of acetyl-CoA. And so during the formation of acetyl-CoA, the acetyl group is transferred from acetyl lipoamide to CoA to form acetyl-CoA. Dehydrolipol transacetylase E2 catalyzes the reaction. The thioester bond is maintained as the acetyl group is transferred to CoA. So as a result of this step, acetyl-CoA has now been generated. But wait, there's more. We're not quite done yet. So there's one more step. And this step involves the oxidized version of lipoamide being regenerated by dehydrolipol dehydrogenase. And so this allows the whole cycle to start over and redo itself. So in this last step, the oxidized form of lipoamide is regenerated by dehydrolipol dehydrogenase E3. And so 2 electrons are transferred to a FAD prosthetic group of the enzyme and then to NAD positive. Electron transfer potential of FAD is increased by its association with the enzyme, enabling it to transfer electrons to NAD positive. And so, like I said, this step is vital in order for the whole process of pyruvate dehydrogenase to start over again and repeat itself. So that is my presentation, and thank you for watching.